I'm going to be doing part 2 of the polynomial and rational functions. So this is going to be the second side of the second practice assignment, and there's also going to be bonus questions at the end. So number 8, write the function y equals 3x plus 5 over x plus 4 in the form y equals a over x plus, that's not meant to be a 4, that's meant to say h, plus k. Okay, so what you want to do here is you're just going to do long division, because you want to simplify this so that we can get it into this form. So let's write out the 3x plus 5. X goes on 3x 3 times. 3 times 4 is 12. These are going to cancel out. 5 take away 12, negative 7. And that's your remainder. So we negative 7 over x plus 4. And then to write this out, we're just going to bring this over here. So y equals 3 negative 7 over x plus 4. That's the same thing as just applying this negative to here and just putting a plus sign in between. So y equals 3 plus negative 7 over x plus 4. And we can just bring this 3 over here. So we'll end up getting y equals negative 7 over x plus 4 plus 3. So that's how you do that. Number 9. So here we're going to be graphing a function, and you want to put all the intercepts, points of discontinuity, and asymptotes. Just by looking at this, I don't think there's going to be any asymptotes. So let's just go ahead and write everything out. So I usually start with my point of discontinuity, and then I go ahead and do my x-intercepts, and then my y-intercepts. And if there was asymptotes, you would write them here, but I don't think there is any in this one. Right off the bat, we know that x cannot equal 4, because if it was, then it would be something over 0, which is undefined. So we already know that our point of discontinuity is going to start with x equaling 4, so it's going to be 4 comma something. Now we're going to have to simplify this so we can do long division so that we can find our x-intercepts. Let's put that inside. So x goes to x squared, times it by x. X times negative 4 is negative 4x. These cancel out. And then negative x plus 4x is going to be 3x. Bring down the negative 12. So x times 3, 3x. 3 times negative 4 is negative 12. These cancel out, and these cancel out, so you're left with 0. So there's no remainder, so that's going to be what y equals. So y equals x plus 3. Now to find your x-intercept, you just put y as 0. So when we have 0 equals x plus 3, we just take away 3 from both sides, and negative 3 equals x. So x is negative 3 when y is 0. And now for the y-intercept, we just put x as 0. So let's go ahead and do that. Y equals 0 plus 3. So y equals 3. So when x is 0, y is 3. And then for point of discontinuity, you basically just do the y equals x plus 3, and you just substitute the point that it can't be into it, because you know that whatever that point is, the y value also cannot equal that. So y equals 4 plus 3, so it equals 7. So when x is 4, or when the graph cannot equal 4, it also means that it cannot equal 7. So it's going to be 4, 7. And then when you go ahead and plot that, your x-intercept, you're going to go ahead and do your y-intercept. And then you go and put your point of discontinuity. So it's going to be at 4 and 7. That's actually just up here. So it's going to look something like that. And that should be how you graph that. Number 10. So we're going to be graphing this function, including the intercepts and points of discontinuity and the asymptotes. Let's go ahead and write out everything. Okay, let's go ahead and start. So what you want to do here is simplify. So instead of x squared negative 3x negative 4, we want to be able to simplify this. So when we have x squared negative 3x negative 4, we can actually do this into two factors that multiply by each other. We need something that will multiply to get negative 4 but add to be negative 3. So we could do negative 4 and positive 1. So x negative 4 times x plus 1. So then when you see, it's going to give you x squared, 1x, negative 4x, negative 4, and so it would be x squared plus x, negative 4x, so that's going to be negative 3x, and then negative 4, so that gives you that. So it's going to equal x negative 4 over x negative 4 times x plus 1. We can see that these cancel out, and if we can get rid of something, we know that that's going to be our point of discontinuity. So we're going to just put up here x cannot equal 4, and it also cannot equal negative 1. But for our point of discontinuity, we know that it's going to be 4 for the x value. So this is going to leave us with 1 over x plus 1. And because we can't get rid of this on the bottom, we know that is going to be our vertical asymptote. Let's go ahead and fill everything in. So first of all, let's do our point of discontinuity. So when x is 4, what is y? Let's go ahead and do that. So y equals 1 over 4 plus 1, so it equals 1 over 5. So when x is 4, y is 1 over 5. Okay, now we're going to do our vertical and horizontal asymptote. So we know that our vertical asymptote comes from whatever's on the bottom, and in this case, y cannot equal negative 1, or sorry, x cannot equal negative 1. So we're going to have, for the vertical asymptote, it's x equals negative 1. And then for the horizontal asymptote, we just get that for whatever the k value is, and because there's nothing there, we know the k value is 0. So y equals 0. And because our horizontal asymptote is y equals 0, we know that we're not going to have an x-intercept because it's never going to hit the x-axis. So for x-intercept, you just put none or just not fill it out, I guess. And then for y-intercept, we put x is 0. So y equals 1 over 0 plus 1. So it equals 1 over 1. So y equals 1. So when x is 0, y is 1. So let's go ahead and do that. So just point at 0 and 1. And then our point of discontinuity is at 4, and 1 over 5 or 0.2. So that's about there. Okay, so we're going to go ahead and do our horizontal and vertical asymptote. So it's when x is negative 1 and when y is 0. Now we're just going to plot based on the equation that we have. So we can see that there's no vertical or horizontal stretch. So you know that when you have a reciprocal function graph, that's just going to go over 1, up 1, over 2, up 0.5, over 0.5, up 2. That's going to do that for both sides. We do have to remember our point of discontinuity here. So you put your circle, and then you just come over. Make sure your line looks better than that. I don't know. That's not very neat. But anyways, this should roughly be what your graph looks like. Question 11. Determine the equation for every asymptote for the function y equals x squared plus 3x negative 4 over x plus 5. So for asymptotes, we could have a horizontal asymptote, vertical asymptote, or a slant asymptote. So we're going to have to find out. So let's just go ahead and simplify the top first. So we can take this. We need something that multiplies to equal negative 4 but adds to be plus 3. So we could do 4 and negative 1. So x plus 4, x negative 1. And this is all over x plus 5. Okay, so right off the bat, we can see that we can't simplify it that way. So we're going to have to do long division instead. So let's go ahead and write out that first equation. And then you do your long division. So this is x. X times 5 is 5x. This is all subtracted. These cancel out. 3x take away 5x is negative 2x. Bring down your negative 4. X times what is negative 2x? It's going to be negative 2. Negative 2 times 5 is negative 10. Subtract this. These cancel out. Negative 4 plus 10 is going to be 6, and that is going to be your remainder. Okay, now we can see that it's actually going to be a slant asymptote because we have y equals x plus 6 over x plus 5, negative 2. And we can see because we have the x out here, we know that a slant asymptote is what we're going to be having. We're also going to be having our vertical asymptote, and you get that from the bottom here. So we know x cannot equal negative 5. So for our vertical asymptote, we have x equals negative 5. And then for our slant asymptote, we get that. Basically, the logic behind it is that the bigger the x value gets, the closer this gets to 0. But even if x reaches infinity, this is never actually going to equal 0. So that means that y can never treat that as 0. So y can never be like x plus 0, negative 2. That's because this is never going to happen. It's going to get very close to it, but it's never going to happen. So we say that y cannot equal x negative 2 because you just get rid of that 0. So this is what your slant asymptote is going to be. And you're just going to put y equals x negative 2 because you know that no matter how big x gets, it's never going to be able to equal this. And basically the slant asymptote kind of just goes like this, and then you have your vertical asymptote like so, and then the graph is going to look like something like this. But you're not going to have to draw it for any of these questions, so that's kind of irrelevant. Question 12. Write the equation of the function graph below in the form y equals a over x negative h plus k. So this already gives us a big hint at what we have to do. We need to find a, we need to find h, and we need to find k. So I usually just go ahead and write those out. We know that this point is going to be what h and k are because of those are our x and y values. Just think about when you're plotting a reciprocal function graph. So we know if it's going over 2 and up 1, we know that our x value is going to be 2, so h is 2, and k, if it's going up 1, is going to be 1. So we already know what that is. Next, we know that when we go from the origin, when we go over 2, usually it would come up 0.5. But we can see that instead of going up 0.5, it's going up 1, 2, 3. So we know in order to get 0.5 to 3, we have to times 0.5 by 6 because 0.5 times 6 is 3. So we know that our a value is going to be 6 because we're timesing the value by 3. So then we just go ahead and write this out. So y equals 6 over x. You have to remember that there's a negative here, so you have to convert whatever you put as the h into a negative, so negative 2. And then you add your k, so plus 1. And that is your answer. Number 13, determine the exact value of k so that x negative 3 is a factor of 5x cubed plus kx squared plus x plus 6. So when it says is a factor, it means that basically when we apply this x value into here, y is going to equal 0. So in order to do that, we just have 0 equals, and then we just apply the 3 because x would equal 3 here, because of 3 take away 3 is 0. So we apply the 3 into the x position. So we're going to get 5 times 3 cubed plus k times 3 squared plus 3 plus 6. So we'll just go ahead and multiply that all out. So 3 cubed is 27. 27 times 5 is 135 plus k times 3 squared is just going to be 9k plus 3 plus 6. So it's going to equal 135 plus 3. It's going to be 138. 138 plus 6 is 144 plus 9k. And basically, we take away 144 from each side, 9k, and then you just divide both sides by 9. So k equals negative 16, and that is your answer. Alright, now we got some bonus questions. Yay! Bonus questions! So we're going to be sketching. I have two of these sketch each functions. Include all intercepts and behavior and general shape. So basically what you want to go ahead and do here is you just start by writing out leading coefficient, and then I like to do my degree. This is just to help with sketching it. If you don't want to do it this way, you don't have to. This is just what I find is the easiest way. So you do your x-intercept, your y-intercept, and then you want to do your end behavior, and then you want to just fill everything out. So our leading coefficient is a negative, so we just put the negative here. We know that our degree is 2 plus 3 plus 1 because we know the 1 is there. So it's going to be 6, so it's even. Put that in bracket if you need to. And then x-intercepts, we know that we get those from here because basically it's when y is 0, what is x? And we know that if any of these inside the bracket is equal to 0, that the whole thing's going to be equal to 0. So we know that our first one is going to be negative 4 comma 0. Our second one is going to be 1 comma 0. We know that our third one is going to be 3 comma 0. And that's your x-intercepts. Now when you go to y-intercepts, you just put x as 0 to find what y is. So let's go ahead and do that. So 0 plus 4 is going to be 4. 4 squared is 16. 0 negative 1 is negative 1. Negative 1 to the 3 is negative 1. 0 take away 3 is negative 3. Negative 3 to the 1 is just negative 3. So we can go ahead and do this first. So negative 3 times negative 1 is just 3. 3 times 16 is 48. So all of these together equal 48. And then we times 48 by negative 1 over 12. So that's going to end up being negative 4. When x is 0, y is negative 4. And then end behavior, we have a negative leading coefficient. So it's going to be the reverse of what the positive would be. And then we have an even degree. So our arms are going to be facing down. And there's just going to be random stuff going on in here. And that's what all the information filled out is. Now you can just go ahead and graph this. So you can start with your negative 4, then your 1, and then your 3. Okay, for the first one, for the x-intercept where x is negative 4, we can see that it has a multiplicity of 2, so that means that it's going to be a parabola. And we know that wherever the x-intercept is, that's going to act as the vertex. And we also know that we have our arms like this and like this. So it's going to come down and hit there. Oh, we should also draw in our negative 4. Okay. It's going to come up. You can go anywhere through that y-intercept. The next one, we can see it's a multiplicity of 3. So it's going to come up and flatten and come back up. And then we see the next one is a multiplicity of 1. So it's just going to go through linear. Like so. It should look something like that. That's not very neat, but it should look like that. Next question. Let's go ahead and write the same thing out. So you want to put your leading coefficient, your degree, x-intercepts, y-intercepts, and your end behavior. So leading coefficient is negative. Degree is 3. So it's odd. X-intercepts, we're going to have to factor this to find it, but we can actually find our y-intercept very easily. So if we plug in 0 for x, we have 0 plus 0, take away 0 plus 24. So we know that when x is 0, y is 24. End behavior, so the leading coefficient's negative and the degree is 3. So we know that this arm is going to be up. We know there's going to be random stuff happening here, and then it's going to go down. So let's go ahead and find our x-intercepts. So you want to go ahead and start by doing your synthetic division. I'm going to do plus or minus 1, plus or minus 24, plus or minus 2, plus or minus 12, plus or minus 3, plus or minus 8, plus or minus 4, plus or minus 6. So this is one of those ones where it takes a lot of factoring, but just for the sake of this, I'm pretty sure that it's plus 6. So I'm just going to go ahead and try that. So you're going to go ahead and do 6 cubed. It's 216. Times it by a negative. It's going to get negative 216. Negative 216 plus your 14 times 6 squared. So you're going to get 288. And then you're going to take away 52 times 6. You get negative 24. Negative 24 plus 24 is 0. So yes, it is 6. So we have x equals 6 or x negative 6. So now we can go ahead and do synthetic division. So we bring the 6 down here, and we bring all of our other numbers over. So first you want to bring down this -1, -6, and then you just add everything here, and you multiply everything here. So 14 take away 6 is going to be 8. 8 times 6 is 48. -52 and 48 is -4. -4 is -24, and this is 0. So we're going to get left with -x² plus 8x -4. So this is going to be your equation. You can take out that negative, so you have negative times x² -8x plus 4. Now we can see that we cannot factor this normally because nothing can multiply to get 4 and then add to get -8. So you're going to have to go ahead and do your quadratic equation. So x equals 8 plus or minus square root of -8 squared -4 times 1 times 4 all over 2 times 1, so 2. Now we're just going to go ahead and do that. So -8 squared is 64. 64 take away 16 is going to end up being 48. So we have 8 plus or minus square root of 48 all over 2. And then 48 is divisible by 24 and 2. 24 is divisible by 4 and 6. So we know that we can take out 2 4s because 6 is also divisible by 3 and 2. So the 2 times the 2 is the 4, and then we have another 4, so it's going to be 2 times 2 on the outside. 8 plus or minus 4 square root 3 all over 2. I'm going to have to bring this back over here. So now you just simplify it with the 2. So it's 4 plus or minus 2 square root 3. So x is going to equal 4 plus 2 square root 3, and x is going to equal 4 negative 2 square root 3. So you're going to have it equal so that we can graph it. You're going to do 4 plus 2 square root 3, which is 7.46. And then 4 take away 2 square root 3 is 0.54. So if you're going to write out the equation, you'd have to bring this negative back down and then bring this over, but we're not going to write it back out because we already have our end behavior. So let's go ahead and plot everything. Okay, I just had to move our y-axis so I could plot this. So we're going to have an x-intercept where x is 6. Go ahead and do that. We're going to have an x-intercept where y is 7.46, so basically 7.5. So it's going to go somewhere there. And then one where x is 0.54. This should be somewhere there. And then we have our y-intercept as 24, so I'm just going to go ahead and put that there and then just say 0, 24. Okay, we know that our end behavior, this arrow is going to be up like this, and we know that this other arrow is going to be pointing down like this. We know that they're all linear, so let's just go ahead and do linear for every single one. Okay, this should not be curved. This should not be curved. It should be straight, but that's as straight as I can get it. So that's the rough idea of what it's meant to look like. Determine the equation of the polynomial function graph below. So to start off, we're also going to get our x-intercepts. So it's going to be -1 and 0, -4 and 0, and then -5 and 0. So that's your 3 x-intercepts. Our y-intercept is 0 and 2. Now we can go ahead and just do these. We also know that we have a even degree because both arms are pointing upwards. And we also know that we have a positive leading coefficient. So to do this, we can see that at this x-intercept, it's going to be squared because it is hitting that vertex point or the x-intercept and it's going back up. It's acting as a parabola. And then for this one, we know that it's linear because it's going straight through, and we know that this one's also linear. So for the x plus 1, we know it's squared. We know for the x plus 4, but it's linear. And for the x plus 5, it's also linear. So this is what it's going to be before we have the a value, which is there. You actually don't need this h and k for this equation. I don't know why I put that there. Okay, so now I'm just going to actually move all of this so we can do the equation. Okay, perfect. Now to find the a value, we're just going to fill in a point on the graph that we know. So we know this point, we know 0 and 2. So when x is 0, y is 2. So we can actually fill this in. This equals y. So we can just fill in the 2 equals a times 0 plus 1 squared times 0 plus 4 times 0 plus 5. So we know that 1 squared is 1. We know that 4, that's just 4. We know that this is just 5. 4 times 5 is 20 times 1 is 20. So 2 equals 20a. Now we just divide both sides by 20. And a equals 1 over 10. So that's our a value. So our equation is going to be f of x equals 1 over 10 times x plus 1 squared times x plus 4 times x plus 5. And this will make sense because we have a positive leading coefficient. And then we have 2 plus 1 equals 4. So we have an even degree. So all of this makes sense with the end behavior and how the graph is shaped. Okay, this is the third last one. You can go ahead and try this first. If you didn't try the other ones already, I'd recommend just trying this one. But anyways, I'll go ahead and do this. So we're going to be graphing this. So first of all, we want to simplify it so that we know what the shape's going to be. So we're going to have y equals x negative 3 over, and we want to go ahead and simplify this. So what multiplies to get 3 and adds to get negative 4? We could do negative 1 and negative 3. So x negative 1 and x negative 3. Go ahead and cancel those out. So we just have to remember that x cannot equal 3. And now we have y equals 1 over x negative 1. And we also know now that x cannot equal 1. So our point of discontinuity is going to be 3, comma. So let's just sub 3 into here. 1 over 3 take away 1 is 2, so it's going to be 1 over 2. We know this is a reciprocal function, so let's go ahead and find the vertical and horizontal asymptotes. So the vertical asymptote is going to come from here, so the vertical asymptote is 1, horizontal comes from here, horizontal 0. So vertical asymptote is x equals 1, horizontal is y equals 0. We can go ahead and graph this now. So let's write in our vertical and horizontal asymptotes. And now we can put our point of discontinuity. So it's at 3 and 0.5. We can do that. And we know that there's no vertical stretch, so we can just do our reciprocal graph as normal, like so. And then when you're drawing this, you just come down, you hit that point of discontinuity, you come down, and you do the other one just as normal, like so. So that's what it should look like. Next question. Write the equation of the function below in the form y equals a over x negative h plus k. So this is where I was talking about where you have to do your a equals and then your h equals and then your k equals. We're going to go ahead and get the point where the asymptotes meet, because that's basically what the positions of the vertex would be. So it's your h and k value. So for this graph, it looks like it's at 1 and negative 2. So over 1, h is 1, down 2, k is negative 2. And now we see that when we come over 1, we go down 1, 2, 3, 4. So instead of going down 1, it goes down 4. So we know that we're timesing it by 4. And now you're going to go ahead and just fill this in. So y equals 4 over x negative 1 plus negative 2. So it's going to equal 4 over x negative 1 negative 2. And that is your answer for that question. Okay, last question. This is just expand using Pascal's triangle. So this is actually very easy. I guess you could do it without using Pascal's triangle, but we're just going to do it with Pascal's triangle. So when you're doing Pascal's triangle, you know that when you have a plus b to the 4, it's going to equal a to the 4 plus 4a to the 3, b to the 1, plus 6a squared, b squared, plus 4a to the 1, b to the 3, plus b to the 4. That's the whole equation for that. So we can just fill this in for x negative 3 equals, and we can just fill it in. So the a here would be our x, and the b would be negative 3. So it would be x to the 4 plus 4x to the 3 times negative 3 plus 6x squared times negative 3 squared plus 4x times negative 3 to the 3 plus negative 3 to the 4. So that's just going to be x to the 4 plus, oh, shouldn't have done the plus actually. It's going to be a negative because of positive times a negative. So 4 times negative 3 is negative 12 times x cubed. And then we have 6 times negative 3 squared. Negative 3 squared is just 9. So 6 times 9 is going to end up being 54. And then 54 times x squared is just 54x squared. And now we have negative 3 raised to the 3. So that's going to end up being negative 27. Negative 27 times 4 is going to end up being negative 108x, because we have to times it by the x. And then we have plus negative 3 to the 4. So negative 3 raised to the 4, it's going to be positive. So it's going to be negative 27 times negative 3. And negative 27 times negative 3 is 81. And that is going to be it expanded. So that's your answer there. And that's it. If you have any other questions, just let me know. And I can either help you directly or I can make another video with some other questions that you have. So hopefully that helped.